Hello and welcome everybody to Pearl Engineering's panel discussion at the 79th Annual Wisconsin Safety Council, and thank you for joining us virtually again this year. This panel discussion will focus on the importance of redesigning systems to be up to date with the most recent specifications in industry. We will decide the disciplines of structure, mechanical, and electrical engineering to evaluate and design safety into our projects that are currently unsafe or struggling to be reliable, focusing on the dependence of safety rules to prevent accidents and keeping workers safe. So we share with you Safety by Redesign. I will be introducing our team of Jeff Pearl, 38 years of service with Pearl Engineering and in industry. He's the principal consultant specializing in structural engineering and project management of industrial projects, and is also a professional licensed engineer in multiple states and provinces. We also have another professional engineer on the call, Mike Anderson, with 15 years of experience. He is a senior project consultant at Pearl Engineering, specializing in mechanical engineering and project management of boilers, turbines, fuel handling, and power industrial process systems. Susan Rice, with 35 years of experience, is a senior project consultant specializing in electrical engineering. She has been practicing electrical engineering for the majority of that time, however, is a by degree mechanical engineer. She specializes in group leadership, marketing, project management, and has experience in converting systems, food process systems, pharmaceutical processes, aerospace testing, and automotive quality control. Myself, Mike Evans, has only 7 years of experience. I'm a mechanical engineering associate with Pearl, and I specialize in project management and operations support, and I will be your moderator today. In total, this panel has over 95 years of combined industrial experience designing safe workspaces for our clients. We'd like to thank the Wisconsin Safety Council for putting on this virtual summit again this year, and we are very excited to be presenting. First off, I would like to have Jeff Pearl introduce our company that he has been an owner and operator for the last 21 years for. So take it away, Jeff.
Thank you, Mike. I very much appreciate it. We're really excited to be doing this Safety by Redesign program. As Mike said, we do have a lot of different services, and we've been in business 21 years, and we're very proud of that. Some of our services include civil structural engineering, and including design of new structures, design modifications of existing structures and plants, monorails and lifting devices, condition assessment of structures, stack, chimney, and ductwork evaluation, platform design, and other things like that. We also do mechanical engineering, including piping and pumping systems design, energy conservation, analysis and design, HVAC evaluation and design, process system assessment and design, condition assessment of equipment, machinery troubleshooting and modification. We use AutoPipe for piping analysis, and we do piping flow and thermodynamic analysis of systems. Further, we do electrical engineering design, including power distribution, control systems, hardware and panel design, and construction packages. We do project management, including conceptual design and planning, procurement and processing services, construction and management and field supervision, and lead consulting. We also do safety assessment services, including plant safety evaluations and improvements, fall protection design and evaluation, OSHA training and compliance consulting, and safety oversight for plant outages. We do design services, including building information modeling with Autodesk, AEC Design Suite. We do drafting services, including rendering services using Revit, 3D project design using Revit and AutoCAD, and we have our own Faro scanners and do 3D scanning of plants. So that's just a little introduction on Pearl Engineering. Please ask us, if any of us, if you have any more questions in that regard. Mike, I'll let you go ahead and lead us on.
The first question will be, what does Pearl Engineering look at when retrofitting for only safety improvements on existing equipment and facilities? Jeff, you're going to be talking a little bit about roof access and safety improvements.
Thank you, Mike. Yes, roof safety is really an important thing in facilities because HVAC systems, exhaust fans, process equipment are so often installed on roofs as they're kind of considered a free floor. But in fact, roofs and roof surfaces are not typically designed to be walkways, but rather for shedding water. That's why they are dangerous for being work surfaces. Further, because these areas are outside, i.e. on top of the roof, they often are exposed to inclement conditions such as rain, snow, ice, and wind, which can make them further hazardous. Roof means of access is also typically not considered critical as it's oftentimes so unsafe. So, however, if equipment requires maintenance such as filters, calibration, adjustment, servicing of all this equipment, there's a hazard for slipping and falling, possibly resulting in a work loss injury or death. The past options of tie-off points have helped, but they won't prevent many work loss injuries because of slippage and falling and breaking a hip or a leg or a shoulder or even a head injury. So because of that, installation of anti-slip work surfaces with handrails and OSHA-compliant means of roof access can make these work areas much safer while working in exposed conditions. Mike, you want to talk about from a mechanical aspect?
Yeah, thanks, Jeff. One thing from my experience, I've seen a lot of misconceptions with what equipment in your facility requires the most safety retrofits. A lot of people think that it's the older piece of equipment. Like you think of a car, you don't have the safety features in an older car, a 50-year-old car, than what you have compared to now. But one thing, a lot of the old equipment has over time, as long as your facility has a good safety culture, been upgraded. It's been kept up to date. So it's in compliance for today's standards. And a lot of that was just troubleshooting and mechanics and operators identifying any sort of risks involved in that equipment and bringing it up, writing a work order for it and implementing it, or having a design firm come in and really look at the equipment for what changes can be made. What I've had my most experience in for retrofitting has been with new equipment. Anytime that you have a new piece of equipment come to site, there may not be there may be some things that were overlooked in the specification of the equipment with exactly how that device is going to tie in to that process. A lot of times it's finer things, and they need to be addressed. Another thing with new equipment, since it is new, you don't have the experience with it. So the operators and mechanics are always going to be identifying, through safety audits and through identifying any near misses and working with it, what obstacles are they facing and what safety improvements need to be made. A lot of time with the break-in maintenance is when these design deficiencies really come out. Sue, what about electrical retrofits?
Yes, thanks, Mike. Before I'm going to talk about retrofitting motors. And before I get into that, I'd like to talk about some statistics for electrical safety. According to the Electrical Safety Foundation International, the electrical injury status for 2019 was 166 fatalities and 1,900 injuries. The highest number of electrical injuries occurred during the construction phase with 43%. The second was during installation, maintenance, and equipment repair, which was at 22%. Now, the reason I'm giving you that is because I'm going to be talking about basically not equipment repair, but the maintenance and equipment retrofitting so it's safer for maintenance and operations. The two biggest industrial electrical hazards are arc flash and electrical shock. And I'm going to be talking about, by retrofitting motors, how we can add protection to the equipment. First thing I want to talk about for this is the remote disconnect. Okay, so older equipment, there may not have been a remote disconnect, and the only way you can lock out is at the MCC bucket or at the circuit breaker panel. The code now states, and Pearl recommends, that all motors have a remote disconnect and they are within the site of motion, so that you know when you are locking out that you're locking out and there's no motion there. And of course, to test it, you need to test it and look and see if there's actual motion or not. So that's the first thing. Then the rest of these then are the motor protection equipment that could be added to motors. So one of the things that's added to medium voltage equipment, such as transformers and feeds, is something called the current limiting fuses. This helps these actually safely interrupt fault current prior to a level where equipment gets damaged. It prevents electric shock. It reduces downtime because you're not actually damaging your equipment. You're shutting it down before it gets to a level where it would damage the equipment. Another item that we would add or retrofit would be maybe put in a relay protection intelligence system. These shut down motors before they get to a dangerous condition. They provide feedback, which monitors and reports hazardous conditions such as overloading, overheating, which happens because of maybe undersizing your motor, or there's not good ventilation, or a piece of equipment jams. There's a phase imbalance. There could be rogue ground loads that happen, or bearing failures. Now, shaft misalignments are 80% of those bearing failures, but other things that cause bearing failures are the locked rotor or vibration issues or running in reverse. And so these relay protection intelligence that provides feedback will help you prevent any dangerous conditions. Also, adding a ground fault circuit interrupter. Those are usually added to submersible pumps, mixers, agitators, anything that's high risk of electric shock, because there is presence of liquid, which could be highly conductive. Another thing that is kind of cool that they've come up with are these Bluetooth devices, so that you don't have to open up an enclosure anymore. You can look at your phone, and your phone, for the maintenance group or operators, they can look at their phone and say, oh, there's a motor overload, and it tells you what the error code is. Right from your phone, you can be 30 feet away and you don't have to open that enclosure anymore. So those are all things to look at. And then there's also arc flash relays. Now, arc flash is caused by a short in a high energy conductor to ground, or a conductor could also be like a human, a tool, conductible fluid. It produces a blistering burst of light as well as a powerful blast. And these relays actually see the light, and they trip immediately before the arc flash can build to devastating levels. So we can retrofit these into switchgear, motor control centers, or panel boards. Very interesting. That's all I have for now for retrofitting motors, protective devices. Mike, what's our next topic of interest?
Great. So our next topic is, what do we look at in our designs in retrofitting equipment for a facility for safety improvement? So what we're going to be talking about is, how do we future-proof when installing a new line at a facility?
For retrofitting equipment, when my first job out of college was in the power industry, and we did a lot of scrubber retrofits on large utility boilers. And there was nothing that these utilities really could have foreseen back in 1970 that they were going to end up needing this equipment down the line. A lot of these scrubbers had to just be kind of fit in however they could be. One facility, a scrubber had to be built in 250 feet above ground because it was the only way to get it there. Another site I was involved in, there was a mile-long ductwork that had to cross over a highway, and the scrubber had to be set off site, and then back towards the stack. So, you think to try to accomplish those retrofit projects, those are big lifts and large equipment, and you have to try to make a large pick, which is dangerous. To be able to make it would have been a lot simpler, and it would have been on a lot smaller scale if it had room for that next step to happen. Some of the best projects I've been a part of, the extra thought and care was taken in to make sure that there was plenty of room for access around equipment. One facility that was built in the last 15 years has made it so that their largest forklift can pull right up to any major piece of equipment, and they can remove a motor, they can disassemble a piece of equipment with a forklift, with 2 forklifts if they need to. It's a lot safer for the maintenance on those projects. Another facility I was just involved in, everything was crammed so tight on new construction that retrofitting projects there are going to be very difficult because it's difficult to even do maintenance in that facility now. But once there's going to be retrofits, there's going to be equipment added over time in that facility. So if you just invest the capital up front and give yourself plenty of space, it's going to make it safer on all your employees going forward. And Sue, what do you look for electrically?
Thanks, Mike. Yes, I'm going to talk about retrofitting in an industrial environment. Now, electrically, we look at 2 different items, or the project could involve 2 different items. One might be if we're doing some upgrades to a building and we want to retrofit some of the parts to make them safer. Another is if we are making some changes to a process, maybe adding a new some equipment to it, to a process. So we would also look at retrofitting for safety. One of the things we do for building is we would look at the switchgear and possibly replace some of the switchgear components that will prolong lifespan and risk reduction. Those are circuit breakers, contactors, and protection relays. There's every year something new is coming out to make it safer to retrofit these items. Another thing that now I'm listing some loads that would be off of these switchgear that we would retrofit for safety. And each one of these over the years have a new technology. So we would have to look at all the loads that are existing in a building, and then what we're going to need to add to it to make sure that first of all, there's enough load so it can handle the any new equipment that we would be adding. And then if it doesn't, we would have to look at ways of reducing some of your power current loads. For instance, adding LED light, which is less of a draw, and a money saver. And actually, it's safer because you only have to go and change them, every 11 years instead of every year. So it's surprising how many items in a building facility that you can retrofit to make the building safer and safer for the operators, the people who are doing any maintenance, I should say, just the maintenance crew for the building. And for instance, like your receptacles, you have to replace them, put GFCI receptacles in. So anyway, that's what and then and also for the building, like any grounding, look and see if your grounding wires are aluminum versus copper. It's going to be there's going to be more continuity if you have copper wiring there for most cases. Look at the degradation of any of the wells, look at the insulation of any of the wiring. All of that, are things to be looking at for buildings. Now, for an industrial process, it's, you're still looking at loads, and you want to do a load analysis on what the existing equipment is. And you need to understand what the electrical consumption is, what's being used on this process. So you would usually typically take your single line diagram, make sure they're up to date. You might require a field investigation to go on site and make sure that your single line is correct and that all the loads are on your single line. And then you may do a load analysis if there's not one already there, and you would go in and take measurements from the feed side of the equipment. And another thing you need to do is understand, okay, if I have on a single line, there may be, pumps A and B, and maybe A and B, maybe B is the redundancy. So you would not, you would never be running those two at the same time. So you can't add the full load current of both of those pumps to your load analysis, because only one is running at one time. So you need to understand the process. And then we would research and study and understand what is needing to be taken out. If you're demoing equipment, what is being taken out and what loads will be reduced, and what like buckets are they coming from, or what panel boards are they coming from. And then we would we need to understand what's new processes being brought in. And then we would just look at vendor drawings and understand what the loads were for that. For instance, we have worked with packaging equipment, and chillers and compressors, presses and chippers, ovens, paint booths, peelers, conveyors. You need to understand the pieces of equipment that you are adding. And because a lot of times you're going to have to retrofit conveyors to match the new equipment, and you may want to reuse equipment. And so understanding this is very vital electrically. And then another thing that you need to take into account. So say you take out a piece of equipment and now you want to install something and you want to use the same MCC bucket. Oh, is it large enough? If it's not large enough, is there another space available somewhere? If not, then you may have to add another MCC line section. If you have to add a new MCC section, do you have actual space, not load space, but actual physical space for that? So there are several things that need to be looked at when you have some upgrades or retrofitting going on for your building or for your process. Jeff, how does this topic affect the structural discipline?
Thank you, Sue. I appreciate your introduction there, and great topic. Yeah, I think that in building in new process line development and installation, we see this so often where a client is maybe relocated a line from another plant, especially with a lot of consolidation going on in industry, or it might be a whole new line being installed. And so oftentimes they don't bother to order the maintenance access platforms for that line. They're kind of like, oh, we'll figure that out later, or we don't want to include that, or that wasn't included. And they get all this process line installed, and suddenly there's no access to the equipment. There's no safe access. There's no way to maintain it. There's no way to remove materials from it. Maybe it's filters or things like that, or accessing to replace filters. And service, it might not have a lifting beam to be able to take that motor down and get it all the way down from the top of an assembly line somewhere. And it can be quite costly when it's overlooked. And I've seen plants where it's just a shame, because it's like, wow, why didn't you think about this? And this is what we do. We do a lot of design of platform access, platforms and access ways. And sometimes it's the low-hanging fruit. I just had a client recently, and they said, hey, we need a platform to get up to this piece of equipment. And I said, well, if the platform is there, it's going to be in the way of access to something else on the equipment. Maybe this is a great case for a unique one-off scissors lift to be designed and built, that they could just order from a scissors lift supplier with a cantilever section and be able to service their needs without having to build a permanent platform. So sometimes we give them advice that doesn't involve us at all. But it's because oftentimes that these facilities end up being unsafe that we see the maintenance guys and operators, they're standing on a bucket or some homemade step stool, and they're leaning over operating equipment and conveyors, and it's very dangerous. And it's so much easier to address it from the start, right? But when not, that's when we talk about safety by redesign, where we've got to be creative and how do we make a walkway to get to that spot? How is that walkway going to be accessed once a shift? So therefore, it can't be just a ladder going up 20 feet. Maybe it has to be a stairway. How are they going to get those tools, that tool belt and tools and materials up that cage ladder? So, they have a rope tied to it versus, hey, we're going to have a stairway or a walkway from another location. So anyway, the upfront planning for safe access is just so important to a new line, and it's much lower than the potential cost of an injury that can really be a detrimental thing for a plant, even shutting a whole plant down due to accident investigation and the like. So, Mike, what else? Our next topic to discuss.
Yeah, so our last topic to discuss today is identifying areas of improvement for material handling equipment to mitigate risk to employees. Sue, you're going to be starting us off with this one.
Thanks, Mike. Yes, I'm going to be talking about material handling for electrical machine guarding. OSHA Article 191.212 states, point of operation of machines whose operation exposes an employee, injuries shall be guarded. When you are starting the design of a piece of equipment, please stop and ask yourself, would you be comfortable working on this equipment? Or would you be comfortable if your loved one had to go to work and work on this machine every day? I mean, at the end of the day, we want everyone to walk away from their job safe with all their limbs, fingers, and toes. I mean, we hear excuses. Would somebody really stick their hand in this running machine? Well, the answer is yes, because it happens every day. You think a piece of equipment is stopped, but it may be jammed. And when you remove the jam, it could spring back or start up. And sometimes you're just not thinking because it's something you do every day. So machine guarding is really important. We use this thinking process when we're starting our design. And at first we, start our design and we have a risk assessment. And then we design to mitigate that risk. Then we fabricate and install, and Pearl doesn't do that, but our contractors do. And then we, our clients' contractors do. And then we do a risk assessment again, just to make sure that we've covered everything in our first risk assessment and in our design. Some of the visible hazards that we see are, and these are just a few, there's many more, are nips, the cutting process, pressing, crushing, shearing, flying and rotating objects. Older technologies that I've seen used before are lifelines. They're like a horizontal cable that is being monitored, and if you breach the cable so it disengages, the machine will shut down. But you can always, if you don't disengage the cable and you just reach over it, you can still get caught in the machine. So you could cause injury or worse. So these lifelines are very rarely used anymore. So for mechanical, we use hard guarding, and the material is like a plexiglass or a woven or welded wire mesh material. We've done the fixed point guards, which are actually the full coverage of a whole module, where it has walls and then on all sides, and then a monitored door. Or for smaller equipment, we've done machine guarding with removable panels. But those removable panels you have to have a strict lockout policy where the machine needs to be locked out prior to removing a panel and usually there's a physical key. It's not just a normal screwdriver or something like that. It's a special key that's used, and people are monitoring that to make sure that it's put in a location where somebody has to come and ask for it and sign it out possibly sometimes. that door or the panels are actually being monitored by a device that will shut down the machine if it's disengaged. But lockout is still always required. What is being used on these doors electrically for the monitoring devices there's an intelligent non-contacting door monitor that you can add to your equipment, and you install a safety non-contact switch to the machine guarding, so the machine won't start if the protective door is ajar, and the machine will stop once that door is opened. It's usually magnetic or photo eye or a locking tongue interlock, and there's other types too. Also, something used is like the safety light curtain. This is used in a lot of times tight spots and that you are just reaching into. It's the sensor takes up little space and there's no blind zones. It is flexible to mount. It's easy to assemble and align, and it is automatic calibration, which reduces commissioning. Then there's the safety controllers, which are if you have several modules that are make up a whole line, and you want like the module before the one that actually is getting locked out. If you want the one before that and the one after both of those modules to stop when the middle module is disengaged, then you can network that together. So they are connected to the safety circuit, they can be connected to the emergency stop, or like I said, network together. And the modules or process will stop all at one time. And you can have your whole line networked together if you want. Then there's a jamming protection relay that is a relay that's based on a system that will perform an automatic shutdown and lock out the machine in 10 seconds after a jam occurs. When there's a jam, there could be a built-up energy, and this would protect you from the equipment moving and for going in there and the equipment moving. This gives you a 10-second leeway, and at what point you still would definitely lock out your machine, lock out power and air for this area. That's it for machine guarding electrical. Mike, what's happening in the mechanical area?
Thanks, Sue. For material handling, a lot of my last 5 years has been spent in bulk material handling and making safety improvements to try to keep the material on the belt, on the conveyor system, or keep it in a chute or a hopper. Keeping the material on the belt or in the chute is going to reduce your housekeeping, and a clean area is always safer. And you also have to look at the two most common areas of injury working around conveying systems are cleaning and performing maintenance. You have material leaving your belt, you run a risk of fire potential. You get a dusty environment. It's bad for people's lungs. You got respiratory issues with all the dust in the air, or you could get in your eyes. Not everyone's wearing goggles, just walking around conveyors, and you might not notice that the area is that dusty, and you get the dust in your eye. If you have a completely sealed, as best as industry standards can be done, a sealed conveying system, bulk conveying system, you're going to have about 0.1% of material loss along your conveying system. At transfer points especially. So if you are conveying 1,000 tons a day of material, whatever that material is, you're going to have a ton of material that needs to get cleaned up manually. So you're putting your employees at risk, having to handle all that material by hand in a lot of cases, or it's getting airborne, or it's laying out. A lot of the material, if it's in a dusty form, you've got flammability issues there. It can lay out where you got slip hazards. It just kind of compounds. When it comes to trying to keep the material on the belt, there's a lot of improvements that you can do, making sure that you have good functioning scrapers that you can add onto your belts. Make sure that your side skirts are there. A lot of times, if you have transition points, especially with sealed systems, you may need to add a dust collection system. Dust collection systems have their own safety issues that you have to take care of, because you are sometimes moving the fine particles where it is in a hazardous air to fuel ratio, because a lot of material is not flammable, but when it is in that powder dust form, it can be. Another thing with belts, just a lot of people don't do it. This doesn't have anything to do with maybe the redesign part. If you're working on a belt project, please secure your belt. A lot of times people kind of look at your belt, you isolate a system and you're locking it out to work on. They don't see that the belt has stored potential energy. So please get a belt clamp and lock out your belt. You will appreciate it. Another thing is chutes. Anytime you have a chute or a hopper, any kind of material transition, a lot of times you have impact points that can wear out. It's important to inspect, do UT thickness readings on your chutes and your hoppers to make sure that you're not getting thin, because you run the same risk of fire potential, or just housekeeping and people having to work in strange environments. There's also a lot of good wear resistant materials that are available, whether it be a UHMW plastic, it could be a ceramic liner that you could look at installing, or like some of the advanced alloys that are on the market now. And a lot of that is just kind of up to your system and the material that you're processing, and kind of working to figure out what's the right material for you. So thanks. And Jeff, what examples do you have from your experience?
Well, I think I'm going to look at this a little bit more ergonomically in this question, Mike and Sue and Mike, in the fact that I'm looking at this from the point of view that we work in big, heavy industrial facilities, such as paper mills, where they're moving these rolls of paper that may be 10,000 pounds of weight, or at least thousands of pounds of weight, that they're moving with clamp trucks, with conveyors, with tow motors and alligator carts. And in doing so, they're able to move them all nice and safely and slowly. And so there's some really great creativity that goes into how they move those large rolls of paper with slat conveyors in the floor, for instance. But at the same time, on a much smaller scale, like in a food process industry, we see plants where the same piece of food product might be handled by 8 different people by hand, moving this piece here and there and up on this conveyor, or taking it off here, or unboxing it. And so every one of those injuries, even if or opportunities, you might say, for injuries, even though they might meet the OSHA compliance of 40 pounds for a lifted load, that doesn't mean that you aren't going to have repetitive motion injuries that can occur, and many of them. And so easily, when people come in all different sizes and shapes and strengths, and then expecting them all to be able to lug this 40-pound piece of food, for instance, that's a dangerous thing, because those injuries are so prevalent and so easily achieved, and they have the same results of being a work loss injury, and sometimes really dangerous and damaging to a human body. So our question is a call of arms, you might say, of a call to arms, I guess, of how come we can't find better ways to pick up that product and move that with something like a mini clamp truck, or a lifting beam, or a conveyor system that would be able to unload that product and get it onto a mechanized piece of equipment to eliminate those injuries. Because again, our experience is the cost of that work loss injury is so much higher than the cost of that quality, that improvement or of a piece of equipment or a conveyor or a chute or a lift table. I mean, we see people grabbing bags of ingredients, powdered bags that look like bags of cement, and they're lugging these things back and forth. They're lifting down off the floor and picking them up and putting them over here. In doing so, all of those are just easy opportunities to hurt somebody and therefore cost that company in injuries. So we encourage people to think about looking at integrating conveyors, jib cranes, lift tables, and means of transferring materials. Mike, what's next?
Yeah, Jeff, that's such a great point. I mean, seeing in industry, like how creative industry can be with lifting and transferring heavy materials. And there's no excuse of why it can't be done for lighter loads, like you said. Mm-hmm. So that does conclude the end of our presentation. Thank you, everybody, for joining us. I am going to talk a couple minutes. One of our senior safety instructors at Pearl Engineering, Scott Burkhart, has 36 years of experience and 5 years with Pearl. Scott is a senior safety consultant with experience as a professional firefighter and emergency medical technician. Scott was actually the deputy fire chief of Eau Claire, Wisconsin, and prior to his retirement and joining Pearl Engineering as the senior safety consultant, Scott was inducted into the Firefighter Hall of Fame for saving a child from a burning building. Now, Jeff, at this point, could you close the presentation for us?
Well, I think obviously you can see by our passion for safety that we very much care about the employees of the industrial facilities that we get to work in. It's an honor to serve those clients, and we do want to bring good value to the safety improvements of those facilities. With having our own in-house safety consultant, as Mike mentioned, who works for many of our clients, we have that insight, and several of us have taken the OSHA 30-hour course, for instance. So in addition, safety is inherent in our engineering work as we do in-house safety training and as we go to plant sites. So not just because that's what's required by the client, but also what we want from our associates to come home safe and sound, like Sue said, with all their fingers and hands and safely back home every night, like we want everybody to be. Our final recommendation is the client should have a safety advocate involved in any engineering design if possible, and if not, after the fact, bringing somebody in, whether it's us or another firm, to help them do an independent audit and make recommendations for improvements that will enhance the safety of that new facility, that retrofit, or anything else that they're planning to do in their facility. Thank you for joining us today.